Welcome to our talk. I'm Shivam. This is my colleague Arne. We are both Android engineers at N26, which is a leading mobile neobank in Europe. This is our agenda for today. We'll do a quick recap of what we think as like design systems 1.0 and 2.0. Why we started thinking of design system 3.0, how we started migrating it, what were some of the API design decisions we made. Finally, we'll talk about what it did for us, what were the achievements, what are the limitations of the approach we took, and if time permits, we can have a short Q&A. So, quick start, what is a design system? A design system is a set of building blocks and standards that help keep the look and feel of product and experiences consistent. I've simply stolen it from this Figma blog, but it's a great blog, and if you want to read it up to upgrade yourself about design systems, please go here. And at N26, we have one such implementation of building blocks. You can take a look at some examples here. This is what our screens look like. There's some definition of amounts, icons, different typography, colors, so on and so forth. One such component in our design system is something that we call the spot icon. The spot icon is made up of two kind of basic parts. One is the icon that you see at the back, which is the N logo. And then we have an indicator at the bottom right. And this icon has 4 states, as you can see. So one where you don't have the indicator, and then we have 3 more states, which are represented as success, error, and warning. And in our design system, this is how this icon was described. So in the view system, which was kind of like our 1.0 of the design system, we would describe this icon with this data class. This data class now directly maps to the properties that we talked about. First, we have the icon URL, and then we have the indicator. This indicator is represented as this enum class, which has the 3 states that we previously talked about, success, warning, and error, and then we keep it nullable so that we can have this no indicator state. And then whenever a dev wants to use this icon, they would take this spot icon view, they would call this bind function with the view entity, and the correct view will be rendered. So then a couple of years ago, we started looking at the compose implementation of our design system, and this is what our migration looked like. So from the spot icon view entity, we started moving to the spot icon entity approach. But the rest of the thing probably feel very familiar. We have the icon URL, we have the indicator type, we have the success, warning, and error states. And then now we move from the view to composable, and in the composable world, this looks like this composable function, which accepts this entity, which is the spot icon entity, and we have a modifier that you can use to provide other parameters. Going a little bit into the details, obviously not the exact implementation, but the implementation would look something like this, where we first render the icon with the URL, then we look at what is the type that was provided to this spot icon, and based on this type, we render the right indicator. And if you don't provide me if you keep it null, then I will not render anything. So now comes a new product requirement, right? Some designer says that we want to have this new icon rendered in place of the previous indicators that we had, and this would be a lock icon. So if we go back to our spot icon, look at the states again. We have the no indicator, we have success, error, warning, and now lock. So this is what our entity looked like before. A good way to support this new requirement would be to remove this indicator type and provide an indicator entity, because now we are basically starting to see that product requirements are changing. We want to start to provide new types of indicators for this indicator, and we want to unblock this for sort of all future requirements, right? So somebody comes in the future, they want to provide another indicator, and this is now completely open by replacing this type with this entity. But what did we see happen instead with our design system implementation is this. So the product engineer added this new type, which was called lock. And in the implementation, this changed to something like this, where they look at whether or not this is a lock. If this is a lock, then you render this URL lock indicator. Then came another product requirement where another engineer wanted to display a new icon, and then they went on and added another type. So now we have this info as part of this indicator type. And then the implementation changes as such. So I hope you can see why this is not a very scalable solution, because product requirements will constantly keep changing. Every engineer will keep adding new types. At the end of the day, if you have like 100 icons, you'll have this huge seal class or like a enum where they're mapping one icon URL, indicator icon every time. So let's think a little bit about why did we choose this not scalable approach, and why didn't we go with the scalable approach? If you ask our engineers, I'm sure like everybody will agree that the good approach would have been replacing the type with the entity. The first reason I can think of is that product engineers want to implement features quick, right? They've been given a Figma design that they look at, and they see that they need to build it, and they're like, what's the way with the least friction that I can build this in the app? And the least friction way, for example, in this case, is adding the lock icon or the other types. The second reason I can think of is that in our setup, in our team setup, ideally the design system must lead these changes. So the product engineer gets this new product requirement. They say that I need to render this new icon. They go to the design system team. They tell the design system that, hey, I need this new icon. Could you please provide, or could you please update the design system so that I can render this? What this means is that now the design system the design system team will have to take a look at this new product requirement, see how they can prioritize it in their backlog because they have other stuff going on, right? And while all of this is happening, your product engineer is blocked because they're not able to build this feature. So even if everybody kind of agrees that this might not necessarily be the scalable solution, we go with it because it makes us move forward. And the third, the cost of introducing such breaking app-wide changes is quite high. So if we go back again to the indicator type, we are replacing it with a completely new type of data, which means that everywhere that this class is used, we will need to update its usage. Probably several tests will break in an app or code base of our size. If this is not hundreds, it could be thousands of places, which makes this process even slower. And therefore, the cost is quite high, introducing more friction. So, well, we go with the quickest approach that can get us there. So, if we look at our design system 2.0 implementation, we can say that evolution is starting to seem quite difficult, right? And while this would have been okay with the 1.0 implementation with views, to me, this Compose should kind of enable this for us, right? Like the whole idea of composability is this promise, in my point of view. So we are starting to kind of lose out on this composability thing. So that's where I start thinking of design system with slots. What is a slot? So if we now have a parent component, which is this composable, instead of accepting parameters so that it can create further child components, it just opens up a slot. And the user or the API dev, the dev in this case, can just provide a composable that fits in the slot. The job of this parent component is now just to take the slot and render it inside. Obviously, you want to lay it out properly, so you put, for example, a box with other layout parameters as part of this box. Another way to kind of think of this is from a single responsibility principle point of view. The parent component now just has the single responsibility of laying out these children inside of the container. It's now not responsible to actually create those children, but to just lay them out. So kind of also aligns with those principles. So now if we look at what V2 was and how we move to a V3, or how we can think about it in this V3 approach, is that the entity is now opened up. We put an icon URL as a top-level parameter. And then we expose a slot for this indicator, which the consumers can then simply provide an indicator with. Now, if we go back and think of this new product requirement, with the slots approach, what would happen is that whenever you want to put a new icon, you would just provide a new indicator with a new URL, all right? So completely opening up the possibilities. The implementation in V2 that looks something like this would go to this, where you just invoke the indicator inside of the spot icon. Obviously, you're laying out, and I'm skipping those details here, but this is the gist of it. Now let's think of evolution real quick. In the future, you don't know how this is going to evolve. Some designer builds up something that's called a tiny button, and they want to use this tiny button as an indicator. And now with the slots approach, you can just put this tiny button as an indicator without having to deal with all the problems that we previously talked about. Now I hand over to Arne.
Yes, thanks Shivam. So I think we've just learned that slots can be really great. But one question you might be asking yourself, should everything be a slot? What is even the candidates? And I think the way we generally go about it is that we say, whenever you have nested components, this might be a slot. Especially if you have like this hunch that it might evolve in the future, or it's just not completely clear. So if we look at this example of the button container, as you can see, this is super simple. It's a container for two buttons, the primary button, which is always there, and the optional button, which might be there and might be not. So you could argue, okay, the developer can build this themselves. But if you look at the implementation, you see that we have two slots, the primary button and the optional button. And the implementation of this function is just some spacing and the two slots. So while doing this might not seem like a big thing, it works really well. It gives us this composability, and we're really flexible if we have some evolution with the button container in the future. And there's even more advantages that we will talk about in the achievements section. We do have, however, also some bias towards simple APIs. So, for example, this primary button, you see that it has an icon and it has a text. And the thing is, the icon is optional, so only the text is always there. So if you think about how Google did the material button, there was a single content slot, and then if you're a feature developer, you have to find the right icon, the right text, and you have the icon. And this works. But in our app, in 90% of cases, you only have the text. So you can make this way simpler on your feature developers by having the text as a string and having an optional icon slot. In this way, for 90% of cases, this is how you build a primary button. So it's 3 lines of code, it's super simple, super nice. Really, yeah, you can love this as a developer. The thing is, this works only if the content will not evolve. So if you think about this hint component, for example, we see that it has an icon, it has a text, and we've discussed with the design system designers that there is 0 plans to change that. So while we might change the background or we might change the color, we're sure that this content is only this simple icon and the text. Because if you start thinking, okay, the content changes, we want to have this, let's say, indicator, then suddenly you get back into this like breaking API changes region that we also had with the view entities. So then if you think this might happen, probably would have been better to use a slot for the icon. So now you have like a better idea when should I use a slot, when not. But if I use a slot, how can we ensure that devs find the right composable? And I want to give a nice solution here, which is these custom scopes. And I will talk about this with the example of the stepper component. It's called a stepper because it's built from multiple steps. And each step has a bullet. As you can see, there's different bullets, and the content can be different things, basically whatever the developer wants. So we have these three bullet types, which is the check bullet, the highlighted bullet, and the empty bullet. And the way we build this is with a bullet slot and a content slot. And then, of course, we can lay it out. We have some horizontal arrangement, and the feature developer can simply build his like feature stepper with 3 step rows in a column, and they have the correct icons, more or less, and the text that the feature developer wants. So basically, what we are fearing is that some feature developer tries to build this, and they choose the wrong icon. So suddenly we get this, and then they don't look at it, they push it to production, and we have this like completely destroyed layout. And what we can do to avoid this is building a custom scope. So then the signature of the step row changes to the bullet slot still, but it is now with the bullet scope. And this bullet scope you would build as an interface, which just has the correct bullet functions. So it's super easy for the developer. There's just 3 to pick. And in the design system implementation itself, you have then the responsibility to pick the right composable that builds a nice stepper. So we go from the original step row implementation to one where we have the bullet scope and the signature, and we instantiate this bullet scope implementation so that we can actually call the bullet function. And in our Node Studio, it looks like this. So yeah, this is a GIF. If we wait for the start, you can see I want to have a new step row, and I get the bullet. I press Control Space, and then there's all the bullets, so it's super nice, easy to pick out, basically 0 chance to pick the wrong composable. Then, yeah, just sort of have to do the rest, but you're already way nicer with regards to API. And there's another trick that we can do here, because if you notice that I skipped in some examples these lines, for example, which aren't always there, right? It's only there if it's not the last row. And also we have some spacing here. It's of course hard to see, but this only occurs if it's not the last row. So, okay, you think, let's put a Boolean on the bullet scope interface. This is the last row. And also, because we want to have the spacing, we put it on the step row. But this becomes the API for the feature dev, then they have to provide this parameter twice, which is of course not nice. And what we can do is we look again at the bullet scope implementation, and we add this parameter is last row there. And then if we look at the actual different bullets, you can see that without changing the interface of the highlighted function, we can provide this as last row parameter. And combined with the implementation of the step row, where we already have this last row Boolean, we can just provide it to the instantiation, and this way we only have to provide this parameter once. So this is last row goes, and this is now the implementation. So again, this is a nice feature, but now we have to talk about something, which is that we actually seldom do these custom scopes. And there's multiple reasons for this, and one of them is actually Figma, because in Figma, it's really easy for our developers to see which components do they need to put. The next reason is, if you look at these interfaces, they become really big, really quick, because now we've always had a super nice example, 0 parameters, but you never have 0 parameters in practice, and so you get like huge interfaces. This is only the check mark. Yeah, you can see that it explodes. There's a nice article from Bumble, actually, where they are talking about something very similar and also some solutions to these problems. And in the end, also, while we were fearing that, okay, if we open up the APIs so much, we have crazy things from our developers, this is not actually happening. Because if they see the huge icon, they think, okay, that can't be right, and they search for the correct icon. So with that said, let's talk about some achievements. And this is a long list. So accessibility. As we have now opened up the slots, we can always put a modifier. Putting a modifier means you can control the semantics much more closely without having to explode some view entity with like 3 different accessibility properties. And because we have access to the modifiers, we also can place test tags. So it's super easy. Let's say I want to check, is the highlighted bullet there? I put a test tag on it. 0 problem. Animations, 0 problem. Because it's a slot, I can just put an animated visibility on there, and now the indicator icon is animated. Personal favorite of mine, concise code. This might not have been super clear, but this is like how you actually build the simplest possible button in like the V2 system. So that's like 9 or 10 lines of code. And this is how it works in V3. So yeah, much nicer. And similarly, if you compare with the material button, of course we have some differences here as we discussed, but it is much closer. So if we have a new dev, it's less hard to get them used to like the, I don't know, 15 or 20 different view entities we have. Another point is platform alignment. So with the V2 system, we often had the situation where basically a designer would design something in Figma and it works, and they ask, let's say, an iOS developer, and they say it works. And then a week later, you come to the Android developer and they say, yeah, but the view entity doesn't support this because it's so closed off. And this was always super annoying, because then you get, again, then you need to modify the view entity, talk to the design system team, and it's a whole thing to do. Of course, now we are much more open. And actually, if you think about it, Swift UI for iOS also uses these, something like the slots. Web with React, also similar. Figma, similar. Android, similar. So we have all the platforms we use on the same like paradigm, and it just naturally aligns. It's super nice. So that were a lot of points where it works really nice. Now we have to talk about one thing that doesn't work so well, which sadly enough is testing again. Because we can place a test tag on all the slots, and that makes it super easy to assert that I put the right text in the slot, or I put the right icon. But what's not so easy is to assert that you put things in the right place. So if you look at this cell component, it has 3 slots, right? Start, main, and end slot. So let's say I built my feature and now I want to assert that the checkbox is in the end slot, not in the start slot. And now how would I do this? Well, now I need to look at the implementation of the cell in the design system. So signature, super easy. We have start, main, and end slot. And the implementation is also really easy. Just have a surface, which we have so we can provide a background color. And we have a row to arrange the 3 slots. So now as a feature dev, I think, okay, easy enough. In my test, let's get a compose rule. Let's find the cell, maybe I place the test tag on it. And then it starts to get really critical, because as you can probably tell, this is really implementation dependent. So now I have to step into the surface, then I have to step to the right child, and then I can assert that it's a checkbox. So now, yeah, we've basically written a test for the implementation. And let's say now I have some time and I find smart implementation. I don't actually need that surface. I can just put a background color on the row. And then you run the tests and you see this fails because the surface is no longer there. So the on-child runs into nothing. And yeah, basically we've guided our developers to write these implementation dependent tests. There's a solution for this, which we still have to build, but it works really nicely, and that is custom finders. So you have a test module and you add the custom finder on cell end, and there you have these implementation specifics. And basically when you change the implementation, you get assuming that you wrote a test on it, you will immediately see that it's wrong and you can fix it. Because then the future developers can just use this on cell end and do their same assertions, but without the need to look at the implementation, which is super annoying, and also without the dependency. So let's go back to Shivam.
Thanks, Arne. So I think you've heard all about slots, how we did it, what we did. Let's take a quick look at what our journey has been in getting and where we are at the moment. So I think this was sometime in last year, September 23, that I started seeing a lot of messages on our chat tool that, oh, I can't do this with the view entity, etc., etc. So I start thinking about this problem. I reach out to the design system team and I say that, hey, I think we should solve this problem. This is something super important. And this is also a time when I'm kind of reading up more about slots, figuring out if there's a way we could use it for our design system implementation. So sometime in November, I present this idea to our Android team. A lot of pushbacks about, no, the design system should force developers into building, they should restrict the API, so on and so forth. And hearing that, I invite the design system team, which was already kind of using slots because they have the slot idea on Figma, they have the slot idea on iOS, and I'm like, hey, can you come to our team and tell everybody else what your experience has been with slots? Are you actually seeing the problems that our developers are concerned about? Once those kind of fears were alleviated, we set up an auditing process. This auditing process was basically to sit down with the rest of the design system team, look at the iOS implementation, the web implementation, see what are the currently existing slots at their end, what makes sense for us to migrate to slots, and then once we have all this data, we start actually implementing them. And since then, we've been slowly migrating our design system implementation to use slots. Today, we've completed approximately 70% of our components to use slots where necessary. As you can see, it's not 100%, even though it's been a few months. It's always about priority and what's more important, product requirements, etc., etc. So things are slow. So with all this information, should you migrate to slots? And it depends, as with everything with software engineering. The first question that I think you should think about is, do you have a strong need to restrict APIs? With the view entity approach, you really restrict the APIs, and changes are much harder to implement. And you should think about how your team processes are like, how your product is like, what kind of company setup you're working in. If your answer is yes, that you do need to restrict it, then slots might not necessarily be the best approach for you. The second question you should ask is, like, do you have tooling support? In our implementation of the design system on Figma, as you can see, when we click on icons or items in the design, we see exactly what this component is and what it maps to in our design system implementation. So in this case, for example, when you click on a spot icon on the design, you see that this is a spot icon. So when you actually go and start implementing this, you would try, or I hope you wouldn't, try to put another icon because it's much more easier to find. The third point and the third question that you should ask is what happens when component needs to evolve? What is your current process like? If you have a design system team, when a product engineer goes to them with these new requirements, are they able to drop everything, start looking at your product requirements, build this? Or is it that it's going to block your development for a little bit, but that's okay for you, right? If that's okay for you, then it's fine. Maybe you don't need slots. For our use case, we want to keep design system as a way to help engineers build stuff and not block them and prevent them from building stuff. So yeah, with all this information, I hope you've learned a little bit about slots, our implementation of slots, and I hope you can make a wise choice about whether this is the right tool for you. With this, we come to the last slide. Thank you for joining us and listening to us.